Hi everyone, in this video we're going to continue with the harder questions from financial maths. So hopefully we'll get through as many questions as possible, but I'm going to try to keep this video to about 30 minutes. Won't do the working for every question, but get you started on them. All right, so let's get started with our highlighter. So Helene won $750,000 in a lottery. She decides to place this money into an investment account. All right, why isn't my highlighter working? What's going on here, guys? Investment account that pays 4.5% per annum interest, compounding monthly. All right, so it's important to note whether it's an investment or a loan, the interest rate, its compounding periods, and obviously the initial amount. How much will Helene have invested, in the investment after 10 years? So let's get to our financial solver. All right, we can delete whatever is in there, so we'll just go to clear page. All right, so the investments for 10 years, you can fill it in as you go down, but I think it's probably a good idea as you read the question, you fill it in. So let's do it that way. So Helene won $750,000 and she's putting it into an investment. So her principal value, because it's going to the bank, has to be negative $750,000. Now, if you're ever unsure, now I don't want to keep going back and forth from this document here. Let me just make it a bit smaller. All right, so this just details all your prompts down here on the left side and the different applications up the top. So it'll tell you what each one means and whether it's positive or negative and gives you a little bit of help. Just make sure you've also got written this part down the bottom. So for final payments, if it's a reducing balance loan, what conditions it is, and if it's an annuity, what conditions. All right, so you can always refer to that document if you're unsure, as well as your summary posters as well. All right, it pays 4.5% per annum interest, so we're going to put that in, so 4.5, and it's compounding monthly, so 12 and 12 here. And we want to know how much is in the investment after 10 years. So we know 10 times 12 is 120, but remember you can always just do 10 times 12 like that if you didn't know what it was. She's not adding any money to it, so it's just going to be 0. So there's her future value. So it's grown quite a bit over 10 years. 10 years is quite a long time. That's 120 compounding periods. So you're earning interest on interest, 4.5%, not really a high interest rate, but decent amount. All right. So after 10 years, Helene withdraws the money from the investment account. All right, let's just write this down because I don't want to forget any important parts. And this calculator is going to disappear as soon as I do this. So let me remember some numbers. 1175. 244. I think it was 0.582. All right, so that's for part A. Obviously, we need to round that to 2 decimal places, so let's go ahead and do that. All right, so that just becomes 58. Good habit to get into if you're not confident with your rounding, to do it to additional decimal places before you round. All right, so part B, after 10 years, Helene withdraws the money from the investment account and places it in an annuity. The annuity pays 3.5% per annum compounding monthly. Helene, all right, let's underline a few things. So she withdraws the money. So she is putting this amount from part A into the annuity. So it's an annuity. The annuity pays 3.5% per annum, compounding monthly. Helene receives $6,000 per month from the annuity. For how many months will she receive that? All right, so we're going to take this amount here. Now, obviously, if she's withdrawn the amount, we can't have that 2 there because that just does not exist. So we can just edit and cut that out. And then I'm going to clear everything. We'll start again. All right, so her principal value, so she's again putting it into the bank. So it's going to be a negative. Let's just put that there. Come on. All right, there we go. And I'm going to paste it in. All right, so there's our amount that we're putting into the annuity. It pays 3.5%. and she's receiving $6,000 per month. So let's put that in. All right, the future value is 0 because with an annuity, it eventually goes to 0, a bit different to a perpetuity, which always stays the same as your initial investment. All right, so PY and CY is 12 and 12. So we want to know how long is this annuity going to last? So I press N. All right, so it's going to last 155 months. Now, I wonder why that's negative. So my payment, because it's money coming to Helene. All right, let's just check that. There we go. I knew I had made a mistake, first of all, because you can't have negative time. All right, so that's why I needed to check. Again, referring to this table would have helped. All right, well, I knew I was wrong because I knew it shouldn't have been negative, but again, using it until you're confident. All right, so you can see so it asks how many months will she receive $6,000. So you can have a look at this $290.82. So that's 290 months plus a little bit extra. It's not quite 291 months. So for 290 months, she will get $6,000. And then on the last month, the 291st month, she will get a bit less than $6,000 unless everything's put on that final payment. All right, so let's just write that number. What was it? 290.82. So for 290 months, she receives $6,000. All right, and then for the last month, the 291st month, she'll receive less than that. But the question asks, how long will she receive $6,000? All right, Helene's accountant suggests that rather than purchase the annuity, she places the money in a perpetuity. Now, before we do that, I just wanted to say if you're wanting to know how much the final amount is, you can just go to 291 and go to future value. So that's how much you should be getting. So if I did 290, let's change that back and go to future value. Oh, sorry. So it's $4,919 after the 290. So if we go to 291 and I click on my future value, so what I need to do is the difference between the 6,000 and the 1,065. So 6,000 minus that. Now, again, it is on this formula sheet, but I did ask you to put it into your bound book. So if your future value is positive, then add this to the value. If it's negative, then subtract it from your final payment. So our 291st payment would be 6,000 minus that 1,065, right? Because there's still a bit of money left over. That wasn't answering any of these questions. That was just a little bit of, add-on that I like to do. All right, Helene's accountant suggests that rather than purchase an annuity, she places the money in a perpetuity. Now, I already know that the payment is going to be less if it's a perpetuity because you're only basically getting the interest. So that she'll be able to leave some money to her grandchildren. Oh, that's nice, Helene. If she places 1,100,000 into a perpetuity that pays 3.6% per annum, compounding monthly, how much will the monthly payment be? So basically, let's just break down while we're clearing everything here. So Helene, lovely lady, thinks, I don't need to live off $6,000 a month. It is actually quite a lot of money. So she's saying, I'm going to put it into perpetuity and just live off the interest. And then when I die, my grandchildren will get the $1.1 million. So I'm just putting in these values as I'm talking. Now, perpetuity is also negative. I'm just going to make sure I've got enough zeros. I think I need to just put one more in. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Beautiful. So let's come back to the N. The payment is what we're calculating. Now your future value is what comes back to you. So Helene, unfortunately, when she dies, the money will go to her grandchildren. And so that's coming back to them. So it's got to be positive. PY and CY are 12 and 12. Now you might be thinking, oh, I've got two blanks here. I've got an N blank and a payment blank, which is what we're calculating. So for a perpetuity, let's have a look at our notes here as well. All right, perpetuity at the end. Oh, I've got number of payments there for perpetuity. It actually doesn't matter. So you can see it's pretty much the same as an interest-only loan in terms of you're only getting the interest. So you could have there, excuse me, number of payments is irrelevant. So we can just put 1. All right, so if I put my payment, oh gosh, where did I go wrong? All right, that is totally not right. What I did when I did the future value, I just didn't count the zeros and I was just waiting for it to line up with the principal value, but I've actually got an extra 0 in there, so let's delete that. That's probably why it didn't work, guys. All right, because that's a huge payment. Imagine getting that amount. Well, actually, no, that's negative, so it's how much you owe the bank. All right, so Helene would get $3,300 each month. So what I mean when you put in N, it doesn't actually matter because your future value and your principal value are the same. So if I just put in 200, let's say she lives forever, maybe her grandchildren are like, oh my God, oh, well, I shouldn't say that, but you know, they're waiting forever. They're like, Grandma, you're 120 years old. And they're like, you know, they've waited 50 years and it's months. So 50 times 12, you're still going to get the same payment. All right, so it actually doesn't matter what you put in there for a perpetuity. All right, so 3,300 each month. I like that question. All right, just make sure I didn't miss anything. Okay, let's have a quick read of this one. Jared opens an account with an initial balance of $0 that pays an interest rate of 6% per annum, compounding monthly. He makes monthly deposits of $500 to the account for 10 years. After 10 years of making deposit, Jared withdraws the balance and places it into an annuity. Also with an interest rate of 6% compounding monthly, he withdraws $500 each month from the account. How much does he invest in the annuity after the initial 10 years? So let me just recap what Jared has done. All right, so I'm going to draw a timeline. So let's start. He started with $0. Interest rate's okay, we can put that in. Every month he adds $500. Right, and then he's obviously earning interest. And he does that for 10 years. So 10 times 12. Right, he does it for 120 months. All right, so after the 10 years of making deposit, he withdraws that money. So let's see what his balance is after that. All right, we'll do that on the financial solver. So we'll clear what we did before. All right, so he's put it in for 120 months. The interest rate was 6%, which is pretty good. Principal value was 0. He had no money. You can't have negative 0, so it's just 0. He does add 500, so you do have to put negative 500 in. And future value is what we're looking for. And then PY and CY is 12 and 12. All right, so he gets that amount. So remember, he's putting in $500 a month. All right, so after 10 years, which is a pretty long time, he's done this 120 times, he gets this number. So 81,939, so 81939. I think I should put the 9 there first, 939. 0.67. All right, so that's how much he has after that 10 years of making that investment. All right, so then he has an annuity. So remember, the main difference between an annuity and an investment is with an annuity, you get money back. But it's your own money. You get your own money back plus interest. All right, so after 10 years of making the deposit, Jared withdraws the balance and places it into an annuity, also with an annual interest rate compounding. Okay, so he now starts with that 81,939.67, and he's taking out $500 each time. But over this time, he's also earning interest, just like this one earned interest. So earning interest here over the 120 months, he's also earning interest here. It's the only difference is he's now withdrawing $500 each month. So he still gets interest, but obviously it's going down over time because the balance is going down over time. All right, so how much does he invest in the annuity after the initial 10 years? Oh, well, there it is, that balance, that $81,000. How much will remain in the annuity after 10 years? All right, so let's go back here. So I'm going to delete to that, copy and paste, because obviously it's withdrawn the money, so we can't keep it to so many decimal places. Let's clear. Actually, we can probably keep some things in there because those two are the same. The principal value, paste that in. I think it's going to have to put it in as a negative because it's going into an annuity. How much will remain after 10 years? So we start off with just under 82,000. So after 10 years, we've still got a lot of money there. Where did I go wrong? All right, so the payment, oh my gosh, needs to be positive. I should really pay more attention, guys. I knew it was too big, all right, because if you've got 81,000, you're taking money out, you can't have more money. All right, so then you're left with $67,141. He's only withdrawing $500. All right, so $67,141. So 120 months. 67141. 0.09. All right, so still earning interest, and 6% is quite a high interest rate. I actually thought it would be a little bit lower than that, so I might just double check my values. Looks pretty good though. So 10 years, withdrawing $500. Okay, well, looks pretty good. All right, let's move on. A couple negotiates a 25-year mortgage of $500,000 at a fixed rate of 7.5% per annum. Right, let's highlight some things. So it's 25 years, $500,000 is the initial fixed rate for 25 years. Yeah, that doesn't exist. For 7 years. Oh no, so it's a fixed rate for 7 years. I was going to say you can't have a fixed rate for 25 years. All right, so let's highlight a few things and then we'll break it down like we did with the previous question. So the monthly repayment is paid each month for 7 years. After 7 years, the interest rate rises to 8.5%. The couple now pay that. Calculate the value of the loan after a further 7 years at a higher interest rate. Round your answer to the nearest cent. So this actually happened to me. I got a mortgage at a really great rate, like 2.9%, and I think I had it for 2 years. And that's when the interest rates just kept going up and up and up. And so by the time my fixed rate ended, it was 6.5%. So a huge jump. But anyway, that's what being an adult is all about. All right, so a mortgage. A mortgage is a loan, a home loan. So we're starting off, so let's just say that it's a loan. So we're starting off with $500,000. Fixed rate of 7.5, compounding monthly for the first 7 years. So we're making repayments of 3,694. All right, so that gets paid every month. So I'm just doing this to show you what it is. So monthly payments. And the couple does that for 7 years. So 7 times, because it's monthly, compounding monthly, so 7 times 12. Remember, we don't need to be able to do 7 times 12. We don't have to go back to the main screen to do that. It is, 7 times 10, 70, 84. All right, but our calculator will do that for us. All right, so let's work out what the balance of that loan is after the fixed rate has ended. So let's clear the page. All right, so 7 times 12, remember, is 84, but you can just put 7 times 4 in there. 7.5 is our interest rate. We're taking out a loan of $500,000, so that's going to be positive. So 500. The payments, remember that goes back to the bank. So it's going to be negative. So 3694.96. Future value is what we're looking for, and payments and compounding periods are 12 and 12. All right, so still owing after 7 years is 437,000. Uh, 437,286.23. All right, so that's the amount still owing after 7 years. And then the interest rate goes up. Actually, I probably should have kept that. Actually, we'll get rid of those two decimals. Oh, we'll leave it. All right, so we're just, I'm just thinking whether we keep it there. If we changed banks, it would actually not matter, so I'm going to take it off. All right, so let's cut that and get rid of everything else. So let's clear the page. All right, so what is happening now? So we've gone down and now the interest rate has gone up. So let's call it a off the fixed loan, off fixed rate. Because remember, we started off with a fixed rate of 7.5% and now we're at 8.5%. So we're starting off with this 437,286.23 amount. We're making larger repayments, all right, because your interest rate has gone up. So 3959.44 each month. And we want to know the value of the loan after another 7 years. So we're going to do 7 times 12 again. All right, so 7 times 12. All right, the interest rate, remember, went up. Only 1% though, but you know, it all makes a difference, guys. All right, remember I cut that, so let's paste it in. Now it is a loan, so I can get rid of that negative. And we're making payments, so that payments have to be negative 3959.44. All right, future value is what we're looking at. So it is a 25-year mortgage, so we wouldn't expect it to be fully repaid. All right, so still owing 338,000. 807.89. All right, so that's how much is owing after another 7 years. All right, so let's not do every single question here. Let's maybe just break it down and you have a go at doing it on your own. So Zian borrows 750,000 for a new home, 8.5% per annum, compounding monthly. For the first 5 years, he only pays the interest. All right, so it's an interest-only loan. So the value of the loan remains at 750,000. So I've got to calculate Zion's monthly payments. So sometimes people do interest-only loans just to make it a bit more manageable, but you can't do interest-only loans forever because you obviously have to repay that 750,000. So he's only doing this for 5 years. So he starts off with 750,000 and he's making these payments, which we don't know how much they are, for 5 times 12. Which we know is 60, but we can put in 5 times 12 into our calculator. Now, after this time, which is 60 months, after 60 months, he still has $750,000, all right? Because he's only been repaying the interest. All right, so these repayments are just the interest, no additional payments off the principal. So before we do that, remember this is on your sheet here. It's an interest-only loan. All right, so your N, it doesn't matter as long as it's something other than 0. So kind of like when we did the perpetuity before. But your PV and your, I was going to say your RV, I've been doing some data work. So your PV and your FV are equal, okay? But your principal is positive and your future value is negative. No, we didn't write that. Okay. So let's get rid of this page, start again. So 5 times 12 is 60. Your interest rate is 8.5 when it wants to work. Your principal value, so it's a loan, so it's going to be positive, so 750,000. Payments, what we're working out. Oh, why did I do 60? Oh, it doesn't actually matter. Because he's doing it for 60 months, but remember we could put any number there that we like. All right, and PY is 12 and 12. All right, so the payments are 5,312 and 50 cents. Now, if I make that a positive, I just want to see what we get. Yeah, so I knew it had to be negative. I just wanted to make sure it was going to be obvious to you because that might be something you need to update on that sheet. So the payments, 5,312, and it was 0.5, but we're not a fancy cafe. We've got to put 50 cents. Okay, so make sure you do that. So only working out the interest. So you could have put 1 there. Remember I said it could be any number other than 0. You also don't want a negative number there. So this value is always going to be the same. Okay, so even if it didn't give us that 60 months, it's still going to be $5,312.50, right? Because it's an interest-only loan. After 5 years, the interest rate increases, oh my gosh, to 9.4%. Poor Xeon. Xeon must now pay more each month in order to pay the loan in full within the original 30 years. He does this by making, oh gosh, there's a lot going on here. 30 years. He does this by making 299 regular monthly payments, followed by a final payment, which is as close to the regular payment as possible. Calculate the new regular monthly payment Xeon must make. Find the final payment. Calculate the total amount Xeon pays over 30 years. How much interest will Xeon pay over the... Okay, I think we should do this one. There's a lot going on here that we haven't covered before. So let's clear the page. We'll start again. All right, I had to do this question again because when I was looking at my answers, I was like, I've made an error somewhere along the way, which you'll probably not know, but I might just tell you what my error was because I still have the financial solver up. I, when doing part B, filled this in incorrectly, so I had a negative 750,000 here. Now, this is why it's extremely important to ensure you take your time and make sure that what is negative and what is positive, because I had these around the wrong way, which meant when it came time to interpreting this down the bottom, our final payments, I actually got it wrong. And I knew I was wrong, yet I kept going, and then I checked my answers with the textbook because these questions are all from the textbook, and I was wrong. So I had to go back and think, okay, where did I go wrong? So it's extremely important that you get your positives and your negatives correct. All right, so let's clear this. And I can't remember what I've said because I did all this question and I'm going to do it again. Do it properly this time. So just to recap, we're borrowing, or we've got this home loan for 360 months. All right, so 30 years is equal to 360 months. Now, of this 360 months, we had our fixed rate, so 60 months fixed rate, and now we're looking at the 300 months. All right, so we had 8.5%, and now it's gone up to 9.4%. All right, so for the 300 months, 299 of them are going to be exactly the same, but the final one's going to be different, and I'm going to explain why it's different. Okay, so the interest rate is 9.4, if it's going to work. Now we are borrowing 750,000. So just make sure that's positive. Oh my gosh. And your repayments is what we're going to work out. So we'll keep that. But remember, it would be negative if we knew what it was. And because the loan's going to be fully repaid, it's going to be 0, and compounding periods and payment periods 12 and 12. So those two are always the same. Now I've got these two blanks. So I know it's going to be repaid in 300 months. All right. So we put the 300 there and work out our payment. Now, if we have a look at this amount, we've got 6,500.665731. Now we can't make all these decimal places because money only goes to 2 decimal places. So I have to round it to the nearest cent. So we're going to have that 6,500 and we're going to round it to 6.67. All right, so that's 299 payments of that amount. All right, after our interest only period. All right, the final payment is always going to be slightly different, and let me show you why. Now, if we made these payments of just 6,567 cents, and we got our future value to 0, notice how my N is not quite at 300. It's just below. It's very, very close. So that must mean my final payment is going to be just slightly different. But I can't, because this is over a long period of time. So over time, even though you might think, oh, it's only a difference of 1 cent, because if I put 0.66 here, then it's going to take longer than 300. All right, so it needs to be rounded. So it basically, if it's over 300 months, then you've got to pay the bank more on your final payment. But because we're paying 1 cent different, so we're actually going to get a little bit less. And that's how I knew that my final payment was wrong. All right. So part C says, well, what is the final payment? So we can have a look at 299 payments. We still have owing this 6,445 and what's that going to be? 7 cents. My dog's going to run outside because he's just heard a bird. There she goes. You can't hear her. You might hear her start barking in a sec. All right. So that's not going to be your amount. There she is. Lucy, shush. That's not going to be your final amount because you're going to have interest. So with your final amount, all right, here we've got this $5.12. So what we do, if you're ever confused, we go to this here, and you don't have this written on your page that I gave you if you're with me in 2025. If you're with me in the future, then you probably do. Now, it's a reducing balance loan. That's the only time you're going to get a final payment question with reducing balance loans. Could be a mortgage as an example of a reducing balance loan, or an annuity. So we're doing a loan. If your future value is negative, then we add this to the final payment. If future value is positive, then we subtract it. So we can see our final value is positive. All right, it's 512 cents. No, 512 cents. Well, it is 512 cents at $5.12, also known as 512 cents. Okay, so it is positive, and so we subtract it from our final payment. When I had my negatives around the wrong way, I interpreted that incorrectly. So it was good that I probably should have checked it on the spot, but I was so confident I was right. I don't know why. All right, so we're going to subtract that $5.12 extra from that. So we get, what is that going to be? 6,495.5. I'm kind of doubting myself here. No, that looks good. $5.12. So $6,495.55 is your final payment, which I think is slightly different. What did we get when we did 299? I want to have a look. All right, so see how it's just slightly different? All right, and that's all just because of the interest. About $50 difference. Okay. part D, calculate the total amount Zen. And when I was listening back to my video, I was like, oh, I'm pronouncing Zion, but I would say it's Zian, but, or Zion, you know, I don't know. All right, so let's have a look at what is actually happening over the 30 years. So remember we had the initial 60 months, and then we had 299 months, and then we had the final month. All right, so we're making 3 different types of payments. So for 60 months, we're doing, where are we? Part A, this $5,012.50. We're making that payment. For 299 months, we are making this $6,567 payment. And then for our final month, we're making this $6,495.55 payment. Now, I probably still have these on my main screen, so notice how I put them in there. So everything was correct except for my final payment because I added it when I should have subtracted it. So that should be 6,495, whoops, not 2.55. All right, and you can see it's changed those 2 values. Okay, so this $2 million value, so let's just do the total. So it's 226894588. All right, so that's how much was paid in total. So you've got this $750,000 house and you're basically paying over $2 million for it. But the thing with houses is, for as long as I've known, they're what we call an appreciating asset. So we've learned a lot about depreciation. So an appreciation is an asset going up in value. So a house it goes up in value. So you can talk to your parents if they bought their house a long time ago, maybe when they first met, or you know, I bought my first property in 2007. I don't live in it anymore, but maybe your parents bought back then and they still have the same house, and they could tell you it's worth a lot more than what it was back in the early 2000s, maybe when they bought it. Or talk to your grandparents or aunts and uncles about it, because I find it fascinating. So yeah, you could spend $750,000 on a house 30 years ago and it's probably worth more than $2.2 million today, because the house prices are ridiculous. So even though you're paying a lot in interest, houses are an appreciating asset. They do go up in value. The thing is though, you know, it's not going to be the case for everywhere that you buy, and you don't also know what's going to happen in 30 years. The house prices might stay the same or they might go down, so very hard to tell. All right, let's move on. You don't need a lesson in, you know, the housing industry. How much interest will Zion pay over the lifetime of the loan? So he's paid this much in total. That's how much he paid. So if you picture him constantly taking money out of his pocket, that's how much he's taken out of his pocket. He had very big pockets and had all this money in his pockets. But he was loaned $750,000 from the bank. So we do have to work out that difference, and that's what I did in this second one. We take away that $750,000 and we get this really big number. So 151, and then I think it's just the same, 894588. So paid this much in interest. All right, which looks like a lot, and it is a lot, but think this is 30 years. So 30 years of your loan. You guys have only been alive for what, 16, 17 years. So 30 years, a very long period of time. All right, I'm going to end the video on this question just because I want to keep the videos around 30 minutes, and I hope that the final one, the third, will be the final one. All right, bye guys.